Hello, I'm Stefan Greber, project leader for LXD, and continuing our current series on storage, today we're going to be looking at ZFS. ZFS is our most of the time recommended storage driver. It's extremely featureful. It works really well with both containers and virtual machines. It supports a variety of additional features that makes it very good for migration and use within clusters. It's pretty good all around, really. Its main downside is that it is out of tree, so it's not going to be found on every single Linux system. On some distributions like Ubuntu, it comes pre-built as part of the standard Linux kernel, so that's great. It's really convenient. We can just use it right out of the box. On some others, you're going to need to install additional packages, or you're going to need to maybe even build it by hand. So that's why we can't just like universally recommend it for everything. But if you have it, it's probably your best bet. Another downside of ZFS is that depending on the way it's configured, it can be reasonably resource intensive, especially on the memory side. This can be tweaked to a level that makes it work really well, even on lower spec system, but that's something to keep in mind. Also, ZFS generally does not like 32-bit systems. I would really strongly recommend against its use on any system that is not 64-bit. Now, a bit of a just kind of overview of what ZFS can get you. So ZFS is a copy on write file system. It started its life on Solaris and then was ported to other BSD operating systems, and then eventually on to Linux through the OpenZFS project ZFS on Linux then turned into OpenZFS. As I mentioned, it's extremely configurable. There are dozens, if not hundreds, of configuration options that can be applied to specific volumes inside it. It supports fast migration through send receive. It can do it with compression, can do it encrypted. It can do a lot of. It's really made to be easy to replicate across multiple systems. It supports both file systems and block storage, which makes it great for LXD and the way we host virtual machines. It supports native encryption these days. It supports native compression as well, a variety of algorithms. And it even has the ability to perform block level deduplication. The way it comes pre-configured by LXD, we've got compression enabled. We don't really have encryption enabled on any of that. We do tweak a few config keys, specifically things like the access time configuration. So that's every time a file is accessed, ZFS doesn't need to keep track of that, which then saves us a bunch of resources. The other options can either be configured through LXD, that we don't try to actively pass through everything because that would be a lot of options, or it can be set directly from outside of LXD through the ZFS configuration tool. Another thing that's worth mentioning before we really start looking at it, and just scrolling through the documentation here to give you an overview of what we have. ZFS can be effectively run on top of a variety of different storage. For the best performance, you're gonna want to use a dedicated disk if you can, or you can use a dedicated partition. Or if that's not an option, then you can use a loop device, which is what LXD will set up for you automatically. And if you already have an existing ZFS Z pool on your system, you can also have LXD consume that, or you can have LXD consume a subset of it, as in a dataset on it. So LXD is pretty flexible as to how to consume ZFS and supports pretty much all of the common use cases, effectively letting you either have LXD create the ZFS pool for you and manage it, or consuming one that you might already have created. There are a couple of quirks to keep in mind with ZFS, however, they're also documented in our documentation here. So ZFS works as a copy on write file system. That's good, that saves you a lot of space. The thing that's worth keeping in mind is that the way it keeps track of the origin of any particular block is done at the dataset level. What it effectively means is if you're, say, creating a massive container and then you copy that as a new container, the copy and write will work just fine. But now if you go and delete the source container and proceed with deleting most of the files from inside the copy, you're not going to actually see the size shrink as it would on something like LVM or on BurFS. That's because the entirety of the source dataset will be kept on disk, regardless of how much of it is actually used by its downstreams. So just something to keep in mind, that actually makes ZFS a bit more solid, a bit simpler in some of its design, but it also can cause additional disk usage. So just something to keep in mind. The other limitation, and one that can be pretty annoying, is that ZFS does not let you restore anything but the most recent snapshot. So say you have LXD configured to create snapshot every hour or so, and you want to revert back to what you had 5 hours or say even a day before that, you're gonna need to delete every snapshot after the one that you want to restore before you can restore it. LXD has a configuration key to do that for you, but it is quite annoying because it means that those later snapshots are now lost. So if you restored something that's too early, you won't really have any way to go back. One solution around that particular problem is that you can always copy a snapshot into a new instance. So you should probably do that first. Then look at the copy, make sure it contains everything you want, and once you're sure it's good, then you can delete the most recent snapshots from the source and then restore to that, and that should work just fine. But it is a bit of an annoying limitation and something we didn't really have any way around. All right, and now just gonna just quickly go through the configuration options before we go into more of a demo of some of ZFS features. At the pool level, if we go down to configuration, there are a couple of 3 configuration keys here that are ZFS specific. The first one changes the ZFS behavior from doing a clone, so effectively a full copy on write copy on creating new volumes, to instead doing effectively a full copy where internally we're going to use ZFS send and receive to have a volume that's completely detached from its parent. That unsetting that particular key would save you space. It would save you space if the parent is deleted, but it effectively turns off most of the copy and write benefits. So it's something to kind of keep in mind. It really depends on the use cases. If you're in a situation where you only ever use an image once, then that might be a good thing to set. In pretty much all other cases, you'll want to stick to the default. There's an option to control ZFS export. That's usually not really relevant to anyone. It only really makes sense if you're using some kind of shared ZFS Z pool or something like that and don't want it exported when LXD shuts down. But yeah, usually just keep that to the default. And the ZFS pool name is effectively an internal thing, or can be used if you want to have a different LXD storage pool name compared to the ZFS internal name. On the volumes, that's where we've got more configuration options. One of them would be the block size. That lets you, so say you're storing data that you know is always going to be happening in like 4 megabytes chunk, say some kind of database, then you could set that configuration key to increase that block size so that ZFS fragments things less. That will get you more performance, but at the cost of very small files effectively using more space. The next option is the one I mentioned earlier, which is ZFS remove snapshot. That's the one that causes any more recent snapshot to be deleted upon the restoration of an older snapshot. So the simple config key you can set. Just need to be aware of the consequences of doing that. Then we've got a kind of 2 related options-ish. So one is ZFS use ref quota. So for that, I just need to quickly cover how quotas work within LXD, within ZFS. So ZFS has two levels of quota. It's got ref quotas and quotas. By default, it uses quotas, which means we would set, say we put a quota of 20 gig on a particular instance. The way it will be enforced in ZFS is that it will allow for 20 gigs of writes, or with 20 gigs of difference compared to what the container or instance was created from. So if you've got an image, even if that image is like 4 gigs large, your instance will effectively be allowed to write 20 gigs on top of the initial 4 gigs of the image. Now, if you set useRef quota to true, that changes LXD's behavior to using the reference quota instead. And in that case, the size of the base image will be included in the consumption of the instance. So again, if you've got an image that's 4 gigs large, you've got a quota of 20 gigs. Now, instead of having 20 gigs that's usable by the instance itself or anything it wants to write, it's going to be down to 16 because the image itself is using 4. And the last one is effectively some way to reserve space within ZFS. By default, there's absolutely no issue with overcommitting as far as LXD is concerned. So actually, out of the box, there's no quota at all. And if you set quotas, you can set quotas that, like, if all were consumed, would far exceed the size of your ZFS pool, which is effectively overcommitting. With this config key, if you set it to true, the space will be reserved. So as soon as you set that, then it will effectively count as used within the pool and no other instances will be allowed to consume that space. So that can be very useful if you've got a specific set of instances that you do not want to see ever run out of space, other than them hitting their quota. You can set that, and then other instances on the system using a ton of disk will never be able to run those instances out. And that's pretty much it for the ZFS configuration options. Our documentation has been all updated and is quite a bit cleaner now. So I would recommend that you take a look at that particular page. Now to switch over to a terminal, here we go. Here I'm looking at one of our test systems. It's been freshly installed with current LXD, so we're running LXD 5.4. And let's just run through a basic LXD init. So I'm just gonna keep hitting enter, and we'll see now that the default for storage is ZFS. That's because we detected the system supports it. Default is to create a new pool. At this point, it would offer me to use a disk or partition if I want to. But the default is not to. Then it picks what it thinks is a reasonable size for a new loop-based backend, and we'll create ZFS on that. So if I just keep hitting enter, I didn't actually do anything. We look at storage list, and here we can see that we've got a new pool called default. It's using ZFS. It's using a loop-backed file on disk, which we can see is 30 gigs large. So that's the default. This is not necessarily optimal because it's effectively like only write to ZFS needs to go through that loop, which needs to go through the parent file system, in this case ext4. But that works just fine. Now, during this this process, I could have said yes and then passed another disk or partition, and it would have created a ZFS pool on that. Or you can do it after the fact if you want. Say, let's create one called dedicated ZFS and then pass in a partition and one v3, I think. There we go. And now we're going to have two ZFS pools. We can see the one that's backed by a loop has the loop recorded as the source, whereas the other one just has its own name. That's because ZFS itself has the concept of a pool name and will keep track of what devices are in there. The actual disks, the disk could change name and it won't impact ZFS at all. Just like the user could go and turn that particular ZFS pool into like a RAID setup or move to another disk or anything. And so long as the name doesn't change, LXD doesn't care, it's all fine. If you want to look at what's going on behind the scenes, you should install ZFS Linux, ZFS util/Linux, I think is the name of the package. And it comes with a daemon that we don't really need, so we can do no install recommends. Just installs that one package, and that will get us access to the ZFS tool itself. And if we want to look at the current setup, here we go. So we can see dedicated is one of the pool, default is the other. LXD creates a tree underneath that. So you've got storage for containers, for custom volumes, for the deleted containers, deleted custom volumes, deleted images, deleted virtual machines, and then images in virtual machines. The deleted entries here are because of that the way reference counting effectively works on ZFS. ZFS will not let you delete the parent, a dataset that's used by any other dataset. So if you've got an instance that was created from an image, that image will not be deletable until the last instance using it is gone. So what happens if you actually delete a container or delete a virtual machine or delete an image or even custom volume within LXD that is currently used by something else? It will be renamed to a random name under that, and LXD will keep track of its use, and as soon as nothing references it anymore, it will get fully deleted. Can actually give you a quick example of that if we just create a quick instance here and we look again. So now on the default pool, the image itself got downloaded and unpacked. A read-only snapshot was created on top of it, and then we can see here the instance itself has been created. Now what happens if I go and delete the image? So I just need to pick its name or its fingerprint here. So I delete this image from the LXD storage, at which point LXD will not list it anymore. There we go. And if we list, we can see that the image was renamed onto deleted. The upside is that LXD is now aware that this image is still in use. So say I delete the instance. Oops. It will clean things up. Now it's fully gone. But one thing that's interesting to see is if I launch it again. Okay, it's here. Then I delete the image again. So that gets us back into having the container exist, but the image being deleted. And look at what happens if I create another instance now. The image is re-downloaded, but it's not going to be unpacked again inside of ZFS. In ZFS, it's just restored. So that avoids doubling the space every time this particular kind of action happens. And again, I can then delete the image. Okay, now if I delete the first instance, we'll see it's still going to be there. And if I delete the second instance, then it goes away. You can also use the zpool command itself to check on the configuration of the different storage pools. So here we can see both of them. We can see that the dedicated is based on a physical NVMe, whilst the other one is based on a loop device. The other thing that that ZFS that we can do, so in this case I'm going to delete our dedicated pool. Okay, and say as the administrator I've created my own pool, which is called external. So that's done through ZFS, not through LXD. So now I've got a new pool here that's called external that LXD knows nothing about. Now I've got two things I can do at the LXD level in that case. One is I could just do external and then source equals external. So just telling LXD I've got a storage pool already, a ZFS pool already, go and consume that. Whoops, give it the name, there we go. And now if I go to this, we can see it's there. And if we look at the content, we can see that LXD has populated it. And now if I delete external, can destroy external, but it's busy. Right, that actually makes some amount of sense. It's a bit of a corner case. I'm not sure what's going on here. Anyway, the thing I actually wanted to show was what happens if we then add a subset. So see, I've got that external pool, and now I want to add a new pool on a subset of it. You can do this with like source equals external / LXD. And what that did is on external, it now created here a LXD dataset inside it, and then created a normal LXD structure inside of that dataset. So that's pretty much all of the different ways you can handle ZFS pools. That last one where you effectively use a subset of an existing ZFS pool, that's very useful if your system is itself running ZFS already. Like if you're using ZFS root, for example, in your system, it makes no sense to then do a loop file on top of ZFS. That would be absolutely terrible for performance. Instead, you want to have LXD do this, where it just creates a dataset on top of your main zpool and then runs on top of that. All right. Now let's just take a quick look. So let's say we want to launch an Ubuntu container. Okay. If I go in there, that's going to be using the default pool, which is 30 gigs large. So if we look out of the box, we can kind of see the 30 gigs minus some overhead. That's fine. Now config device override U1, and I want to override the size of that instance to 10 gigs. Now we can see we're down to 10 gigs. And here we can see the current quota is applied and how much space is effectively being used. So let's say we copy U1 to U2 and start U2. So now U2 should be near identical to U1. Yep, I get exactly the same behavior. And if you wanted to change, so if you go look at the volume list default, volume set, and do container U1, ZFS quota. What did I miss? Oh, I missed the full name. Okay, so we're gonna move them to using ref quotas, and then change their quota a bit. Config device set U1 root size 5 gigs and 5 gigs. So that's how you actually apply a storage volume config directly to an instance. We can see the ref quota. So something you can actually do is pull the full config and then look for what's locally applied. So we currently see the quota is applied, the ref quota is not, which is interesting. And that might actually be a bug. I need to investigate that. Normally what I would have expected to see is ref quota here being set instead of the quota here being set. I'm not sure why it didn't do that. Let's see if it's a bug where it's just reversed, maybe. So again, I'm just gonna change that here and force a quota change on the instance by doing this. So let's do 15 gigs on U1 and U2 and see what that looks like. Nope, it's still incorrect. That is interesting. I think there might be a bug there. ZFS, LXD 5.4 changed a bit how we handle those keys. That looks like a bug that will get sorted within the next couple of days. So hopefully by the time you actually watch this video, this will be sorted and will behave the way it should be. Normally what I would have expected to see here is actually the ref quota being set instead. Let's go behind LXD's back and actually do what it should have done. So we'll do quota none. Set, I think it's the other way around, isn't it? So quota none. And then ref quota 15 gigs. Okay, so now if we look at U2, that's the one we didn't touch. It looks like this. U1 looks like that. And what we can actually see, it's a bit subtle in the way ZFS reported. So the used value includes the image in both cases. But what we've seen is that the original effectively had a larger total size that it could work with because it had a tiny bit more space thanks to those 230 megs not actually counting against its own consumption. Whereas the other one, we can see that the size is the fixed 15 gigs we've put in place, of which 233 megs is used. So it's the quota mechanism in ZFS can take a little while of getting used to, especially because of the way it's reported, like it is here. But that's effectively how it works. Like if the image was 4 gigs large, here we would actually have seen it go up to 19 gigs. And then used would be 4 gigs, which would then give us the 15 gigs available out of the box. Whereas this one would have showed 15 gigs, 4 gigs used, and then of which would have 11 gigs available. So that's effectively how the quotas and ref quotas work in ZFS. I don't really have a lot more I can show on ZFS itself. Maybe just to wrap things up, as I mentioned, there are a lot of options that you can use on ZFS. Like for example, if I do get all on this particular instance, it will show you all of the configuration keys. Apologize, it doesn't fit very well on the screen, but it will show you every single one of the configuration keys you can set. And in general, it's fine to go kind of behind LXD's back and set those, except for those that LXD natively support. So that's effectively block size, record size, quotas and ref quotas. Those are supported, are directly handled by LXD and shouldn't be messed with. The other thing that we can look at is what's LXD setting itself by default. So that's at the root of the storage pool here. So directly on the default Z pool, we can see that LXD has compression enabled, allows for devices to be created, allows for executables to be executed from those file systems. That's obviously needed to run any kind of container on it. Allows for security binaries as well. And then those two options combined effectively lets you do the advanced POSIX ACL. So that's like all of the ACL storage in Linux. So using setf ACL, getf ACL. And also storing all of that as extended attributes, which is what the xadder SA option does. It lets you store effectively standard Unix extended attributes on the file system as is needed for ACLs, but also for file capabilities, for SC Linux labels, for all of that kind of stuff. So that's pretty much what we set by default. But say you wanted to change to a different type of compression, you could do that. That won't really impact LXD in anyways. If you wanted to encrypt your pool, you could also use the ZFS encryption options, and LXD will just kind of go with it. It just assumes the pool needs to have been unlocked prior to it doing anything with it. But that should just work, and we've seen a number of users do that. So I hope this was useful. This look into ZFS. It's definitely our, I guess, most featureful storage driver. It's, well, especially for local storage. One could probably argue that Ceph actually has more features, but it's also not something you can really use on your laptop, whereas ZFS totally is, and really provides a great experience with LXD. It's not always the fastest, but it's definitely the more featureful, and it's very, very reliable. So on that, I hope this was useful. If you've got any questions on ZFS, please leave them below on our community forum. And I'll see you on another storage related video very soon. Thanks. Bye.